Hi, this is a demonstration video of Annie, an intelligent tutor for exploratory learning environments, and Fix-It, an exploratory environment built to evaluate Annie's abilities. My work attempts to merge the best features of two proven forms of computer-based instruction. Specifically, I want to bring the precise individual adaptation and dynamic scaffolding of ITS into the highly autonomous and exploratory worlds enabled by modern digital game technology. We'll start with Annie. Annie creates and directs a plan-based tutorial session. The screen you're about to see shows Annie's Game Director window with some of its C# code in the background. Now Fix-It. Fix-It simulates the inside of a computer so students can learn about computer security and malware. Fix-It receives direction from Annie through a TCP/IP messaging interface. The graphics look much better in person. Now that little orange box is a mouse droid, which carries packets of data from one part of the computer to another as directed by the owning process, in this case the large orange panel. Using the surprisingly loud Investigate tool on the panel provides student with current information on that process. Similarly, applying it to a droid provides its source, destination, and payload. Annie requires a plan-based description of the exploratory world. This can just be read in from an XML file, or the designer can make use of Annie's GUI. Here, I am changing the prompt associated with one particular environment to insert a plug for AI Ed 2011. A key point of this demo is to show how Annie provides scaffolding to the student. In this next clip, Annie will guide the student to perform the action we just edited, which will pull up prompt text I just changed to insert the plug for AI Ed. I know the text is too blurry to read here.
You need to go to AI in Ed 2011 to see this demo live and move to the location.
Annie does not have any built-in knowledge of any particular domain or environment, not even Fix-It. Its knowledge base is built at runtime based on its inputs, as well as a built-in messaging interface with a web-based automated partial order planner. Through this interface, Annie receives a full graph of complete and incomplete plans, which it uses internally for reasoning. Specifically, it analyzes individual plans, individual actions in plans, to highlight the causal connections between different actions in the environment. This all happens internally at runtime, but all the graphics I've shown here are provided by Annie's GUI to help the tutorial designer or to show during a demo. Like many ITSs, Annie's core loops over the possible tutorial actions while updating its student model and considering opportunities to provide scaffolding. The scaffolding can be subtle or can be more emphatic when Annie thinks that the student is stuck. The next scene shows that if the student continues to fail to acquire the tool required to solve the first learning challenge, Annie will eventually direct Fix-It to just show it where it is.
The tool you need is located
Control's taken
here.
away from the student here, and it's shown as cutscene or video.
Slow response time. Please investigate.
Now the student knows where to go and picks up the tool that's required.
Use the scroll wheel on the
Now, the
mouse
whole
to
time this is
select the
going
right
on,
tool.
Annie continues to log its interactions with the game, and all of that's in the dark blue window. And in the purple window, it shows all the updates it makes to the student.
Slow response time.
Here the student successfully completes the first challenge. The sky turns blue,
Good job. Are you
and the
ready for
student
the
takes
next
a
challenge?
celebratory hoverboard ride. Bet you won't see this in any other time.
A network slowdown has been reported.
Went out
Network
to the
traffic
disk
has
drive.
slowed down.
Thanks, Marty
Please
McFly.
investigate.
And thank you for listening to this explanation of Annie and Fix-It.